Hey everyone, Glen here from Sustainable Living Ideas. Today we're diving into how a solar charger works, what components it uses, and how you can put together your own simple, safe setup for powering small devices using nothing but sunlight. Solar energy is clean, silent, and incredibly handy when you're outdoors or the power goes out. Instead of relying on batteries or power banks, you can store sunlight in a compact power pack and recharge your gear anywhere. Solar chargers also teach us how renewable systems work. You literally see energy flow from sun to socket. Think about it. You're not just carrying a battery, you're carrying your own mini power plant. This means you have an endless supply of energy as long as the sun is shining. It's perfect for camping, hiking, or just keeping in your emergency kit at home. Unlike fossil fuels, which are finite and create pollution, solar energy is a gift from the sky. It taps into the most powerful and reliable energy source we have. This process of converting sunlight into usable electricity isn't just practical. It's a powerful lesson in sustainability. It connects us directly to the natural cycles of our planet. By building a small system like this, you gain a deeper appreciation for how large-scale renewable energy grids function. It's a hands-on way to understand the future of energy right in the palm of your hand. Every solar charger has 5 key parts. The solar panel captures light, the charge controller regulates voltage, the battery pack stores energy, and the USB module delivers a steady 5 volts. All of it sits inside a weather-safe case with a fuse for protection. Think of it like a mini ecosystem. Sunlight goes in, power comes out, and the controller keeps everything balanced in between. Let's break these down. The solar panel is the star of the show. It's made of photovoltaic cells that get excited by photons from the sun, creating an electrical current. But that current isn't steady. It fluctuates with the intensity of the sunlight. That's where the charge controller comes in. It acts as the brain of the system, taking the raw variable power from the panel and converting it into a stable voltage that's safe for your battery. Without it, you could easily overcharge and damage the battery. Next, the battery pack. This is your energy reservoir. It stores the electricity generated during the day so you can use it anytime, even at night. The USB module is the final step, taking the stored energy from the battery and converting it to the standard 5 volts that all our phones and small gadgets use. Finally, the enclosure protects all these delicate electronics from rain, dust, and bumps, while a fuse adds a crucial layer of safety, preventing short circuits. Here's how the current flows. The panel's positive and negative leads go into the controller. The controller routes safe, regulated current to the battery. Then, the USB port draws from that stored energy. Simple, right? The important part is voltage regulation. It prevents overcharging and keeps your battery healthy. Let's visualize this path. Imagine the solar panel as a water collector gathering rain. The wires are pipes carrying that water to the charge controller, which is like a smart valve. This valve checks how full the water tank are batteries. If it's getting full, the valve slows down the flow to prevent it from overflowing, which is what we call overcharging. Once the tank is full, the valve might shut off completely until some water is used. When you plug in your phone, the USB port opens a tap on the tank, drawing out the stored energy. The controller ensures this whole process happens smoothly and safely. This regulation is critical for the longevity of your battery. Constantly overcharging a battery can reduce its capacity and lifespan, and in worst-case scenarios, can even be a safety hazard. So, the charge controller is the unsung hero that keeps your entire system running efficiently and safely for years to come. To keep things safe and functional, start with pre-made parts. For small devices, a 10 to 20 watt panel and a 5 amp charge controller are plenty. Pair that with a lithium-ion power bank that already has built-in protection. Certified USB outputs ensure stable voltage. Buy, don't build, your cells. It's safer, faster, and still fully DIY when selecting a panel. The wattage rating tells you how much power it can generate under ideal sunny conditions. A 10-watt panel is great for trickle charging a phone, while a 20-watt panel will charge it faster or handle a couple of small devices at once. For the charge controller, the amperage rating should be higher than what your panel can produce. So, for a 20-watt panel, which produces a little over 1 amp, a 5 amp controller gives you plenty of headroom and safety margin. The most important choice is the battery. Instead of working with raw lithium-ion cells, which can be dangerous if mishandled, use an off-the-shelf USB power bank. These already have protection circuits built in to prevent overcharging and overdischarging. They are designed for safety. Finally, make sure your USB output module is certified. This ensures it delivers a clean, stable 5-volt current, protecting your sensitive electronics from damage. Using pre-certified ready-made components makes your DIY project both fun and incredibly safe. Here's the concept of assembly. Mount the panel on a small board or case. Plug its leads into the controller's input. Connect the controller's output to your protected battery pack. Finally, add the USB port to the controller's load terminals. Always keep polarity correct and avoid open wiring or unprotected lithium cells. Let's walk through the connections. Your solar panel will have 2 wires, usually red for positive and black for negative. These connect to the corresponding solar input terminals on your charge controller. Next, your controller will have battery output terminals. You'll run a separate pair of wires from these terminals to the input of your power bank. Many power banks can be charged via a micro USB or USB-C port, so you might need a cable you can safely adapt for this connection. The final connection is from the load terminals on the controller. These are designed to power devices directly. You'll connect your USB output module to these terminals. This setup ensures the controller can protect the battery from being drained too low by cutting power to the load if the battery voltage drops. Remember, matching positive to positive and negative to negative is crucial. Getting it wrong can damage your components. Keep all your connections insulated and secured within an enclosure to prevent accidental shorts. Once everything's connected, place the panel under direct sunlight and watch the charge indicator light up on your controller. Try charging a small light or a phone. Adjust the panel angle for the best results. A good rule of thumb is to tilt the panel at an angle roughly equal to your latitude for maximum exposure throughout the year. For example, if you live at 40 degrees latitude, tilting your panel at a 40-degree angle from the horizontal will give you great performance. You'll notice that the charging speed changes depending on the time of day and cloud cover. Peak sun, usually between 10 a.m. and 2 p.m., will give you the most power. When you first test your setup, use a device you don't mind experimenting with, like a small USB fan or an old phone. Watch the indicators on the charge controller. They'll tell you if the panel is charging the battery and the battery's current status. This initial test is the most satisfying part. It's where you see your creation come to life, turning pure sunlight into tangible, usable power. It's a fantastic feeling of self-sufficiency. When you've mastered the basics, try some simple upgrades. Add a small voltmeter to display the charge level, or link to panels in parallel for faster charging. Mount your charger on a backpack, take it camping, or keep it in your car for emergencies. A voltmeter is a fantastic addition because it gives you a precise reading of your battery's voltage, so you know exactly how much power you have stored. To connect to panels in parallel, you simply connect the positive wires from both panels together and the negative wires together before running them to the charge controller. This doubles your current, effectively halving your charging time, but make sure your controller can handle the extra amperage. The possibilities are really endless once you understand the basic principles. Check the links below for educational resources and pre-made component kits. If you found this video helpful, hit like, subscribe, and share it with someone who loves off-grid living. I'm Glenn, thanks for watching.